Welcome back, my pre-algebra students. We are in lesson 68. We're going to talk about percent word problems and visualizing percents that are less than 100. So we need to remember a few things. We need to remember that when we see the word of, that means to multiply. If I could actually write that correctly. There's just a few too many. There we go. That's much better. And when we see the word is, that means equals. And when we see the word or the symbol percent, that means out of 100. And we also need to remember how to turn percent into a number that we could actually do some math with. And the way we do that is by taking the percent and turning it into a fraction, which then allows us to turn it into a decimal. For instance, if we have 25%, then we can put 25 over 100 because it means out of 100, right? That's our number. That's our denominator. And then if we get on the calculator and divide 25 by 100, we get 0.25. And that is the format that we use for any number whatsoever. Whatever this number is here would be the number over 100, which would be the number behind the decimal. Okay? Another way, let me show you. You're only going to have two decimal places. So if we said 43%, that'd be 43 over 100 or 0.43. Even if we have a number bigger than 100, it works the same way. Let's say we had 115%. That'd be 115 divided by 100, which would be 1.15. Easy peasy. It's always, if you have two zeros here, then you have two decimal places here, and you put that decimal right there. Okay? That is how it works. Percent to fraction to decimal. And if you're not sure exactly where the decimal goes, just get on your calculator. Okay, let me pull the calculator up. You just get on the calculator. I can't speak today. And you divide the fraction. 25 divided by 100 equals 0.25. Right? 43 divided by 100 equals 0.43. Again, the same. 115 divided by 100 equals 1.15. Okay? I would urge you to make up some percentages and put them over 100 and then divide them on your calculator. See the pattern. Once you see the pattern, it will click and it will make complete and utter sense if it doesn't already. So let's move on to our first practice problem. I'll clear the page. So let me type that in for us because my handwriting stinks. All right, our first problem says that sales tax, that should be in, no, that's right, sales tax is 5% in Maryland. Apparently Miss Tracy can't read either. Joey bought a pair of basketball shoes for $62. How much sales tax did he pay? So there's two ways to do this. We know that $62 is the cost and that 5% is the sales tax. Well, we need to turn that into a number that we can use, right? So we could either go and use the fraction or we could use the decimal. Now, if we use the decimal, the division here has already been done for us. So that's probably going to be the shorter way to get there. We'll do it both ways just to see. So in order to find sales tax, we're going to multiply the percent times the cost of the item. So we are going to say 5 over 100 times 62. We'll put that over 1 because that's a whole number, right? That's going to equal 310 over 100, which is going to equal $3.10 or 3.1. And we know this is money, So this is going to be money, right? So $3.10 is how much sales tax. Now, if we did that using the decimal, we could say 0.05 times 62 is equal to 3.10. So this way is a lot faster because the division here has already been done for us. When we go from fraction to decimal, we divide. So if you want to do it the fast way, do it this way. If this is the way that makes sense to you because this is how you see a percent, you can do it that way too. Either way, we got the same answer. So it's all about which one you prefer. But this way is faster because you've already done the division on the front end. And you don't have to do it after you multiply because we did it before we multiplied. Now, this is one of those situations where if you've ever, like your mom ever gave you $5, you could buy something on your own at the cash register for the first time, and you picked out $5 worth of something, and you took it to the register, and they're like, okay, well, this is going to be $5.35. That's because Mississippi has a 7% sales tax. So if it was $5, let's say it was exactly $5, right? And we have a 7% sales tax in Mississippi, the decimal for that would be 0.07, right? So 0.07 times 5 is equal to 0.35. So if you had $5 worth of something, your total would be $5.35. You see how it works? So for this guy in his basketball shoes, he actually, even though the shoes cost $62, you have to add tax onto that. So he's actually going to spend $65.10. So when you ask your parents to buy some $50 thing for you, right? You ask them to buy something for you that's $50, they're actually going to have to add $3.50 to that. You can't do it for $50. It's going to be $53.50 because there's tax on everything. That tax is what pays for roads and sewer work, and it helps pay for government officials' salaries. It helps pay for public school systems, which I know we don't use, but that's okay. But the tax helps support your community, helps pay for firemen and policemen and things like that. So there is a reason for sales tax, and you do want to pay it. But it stinks that it makes everything cost more. All right, so let's move on to the next problem and talk about a different type of percentage that we're going to figure out. And I'm going to type it again because my handwriting still isn't great. All right, so this problem is actually a little bit more wordy than what I have typed here. It actually says, the big baby weighed 15 pounds. Mama weighed him a week later, and he weighed 18 pounds. Mama could not believe it, a 3-pound increase. Mama wondered, what percent increase is this? I kind of boiled it down. The baby weighed 15 pounds this week 1. 1 week later, the baby weighed 18 pounds. What percent increase is this? So what we have to do is restate the problem in order to put the numbers into this, right? So what we need to say is, what percent of 15 is 3 pounds? Okay, what percent of 15 pounds is 3 pounds? That's what we have to do. So the way we need to set that up is we need to say, we know that of is multiplication and this is equal. So what percent of 15 is 3? Percent times 15 is equal to 3. That's our problem, right? So 15p is equal to 3. So that means we divide both sides by 15. Does that make sense so far? So the percent is equal to because 15 over 15, that's 1p. 3 divided by 15, we can reduce that fraction to 1 over 5. And when we use the calculator to divide 1 by 5, we get 0.2. So if we have 0.20, right, or 0.2 as our decimal, that becomes 20 over 100 as our fraction, which equals 20%. So our percent increase was 20%. He increased 20% in weight from 1 week to the next. That's how we would solve that. All right, let's talk about visualizing percents less than 100. Let me clear this. Often it's helpful to draw a diagram when we encounter problems. And with percents less than 100, it may be, that's something that you need to do. So a percent less than 100 always indicates that a number is being divided into two parts. To illustrate this, we use a two-part diagram to analyze the following statement. 30% of 140 is 42, right? So literally that would be 0.3 times 140 equals 42. That would be how we would write that. So what we would show here on this diagram would be that 140 is 100%. And on this side, we would show the diagram saying that this is 30%. And the difference between 30% and 100% is 70%. So you're splitting it into these two parts. 30% is 42 and 98 is 70%. And we get 98 by subtracting 42 from 140. So you're basically visualizing the two sections that you have divided this total amount into. You do not have to do this for me, for my class, or for Miss Emma. All you need to do is be able to do this. If you can get the right number, right, that's what I care about. If you require for yourself to see it like this, then do it like this. It's perfectly fine. If you don't need this step, if you can already picture it in your head without having to draw it out, don't draw it out. I want you to get there in the way that is the most efficient and the most accurate for you, okay? It is about your understanding and your mastery, not some little extra twaddle. I hate to call it twaddle, but if you don't need it, it's twaddle. If you do need it, then it's necessary. So it's whatever is necessary for you. That's what matters. Number 68.3. Let's do that problem. All right. We are going to complete. This one is just a diagram. So this is the problem. We have 100%. And it is 600. And we are asked to find out, we have 180 here, and we have 70% listed here. So it wants us to find out how much is this percent and how much is this number. So obviously, if this is 70%, then this number has to be 30%, right? And if this is 600, we subtract 180, and we're going to be left with 420. Easy peasy, right? We can see that. All right, so let's do 68.4. And this one actually requires typing, so give me just a second. All right. Ewan was a smart shopper. He got a great kilt for $433.65. It was 30% off the original price. What was the original price? So we have to envision that, and we have to say to ourselves, how are we going to set this up? So we know that 30% off, all right, so that's 100% of the original price. The original price is 100%, right? And this is 30% off. Off is another word for minus. So we're going to have 100% minus 30%. So he paid 70% of the total of the original price. So 70 over 100, 70% is what he paid. This is the original amount. This is the discounted amount. The discounted amount that he paid was $433.65. We don't know what the original was. That's what we've got to find out. What was the original price? So this is how we set it up. We know that it's just like a proportion, only we're using a percent to set up our ratio. 70% over 100%. Right? You see that? So now we just cross multiply like we normally do. So 70x is equal to, and because this is 100 times this number here, we just move the decimal back, 43,365. Now we divide both sides by 70, because 70 over 70 is 1x, right? But whatever you do to one side, you have to do to the other side. So now I'm going to use my handy dandy calculator and say 43365 divided by 70 equals $619.50. And I just converted that into money. It was 619.5. We know money has 2 decimal places because there's 100 cents, right? Put the dollar sign on there. The original price was $619.50. So he did get a good deal, and that's perfectly fine. Alrighty. Now remember, I told you that you can check your work by taking the unknown number and putting the answer in its place and seeing if you can reduce to this fraction here. Right, so the easiest way to do that is to divide the first number. So let's do that. So 43.65 divided by 70 is 61950, or 6.195, right? So 6.195 is what we have. That's our scale factor. So multiplying this number times this number gives us this number. Multiplying this number times this number gives us this number. So when we can multiply both numbers by the same factor, 100 times 6.195 gives us 619.5, and 70 times 6.195 gives us 433.65. So when we can multiply both numbers by the same factor and get this fraction, then we know that the answer that we have received down here at the bottom is correct. That is a way to check your work. All right, and that is the last problem we have for this lesson. So I will see you in lesson 69.